Okay, hello ladies and gentlemen. So we're back for the conclusion of this part of our unit. This is the last thing that we'll cover before we start mixing it all together, practicing, and getting ready for our test, which is 2 Fridays from now. Okay, so determining an exponential relationship from a table of values. I actually showed you guys a little bit of this before with this value, and so we'll do it one more time. Recall that what we talked about before is if we find the difference from here, so 25 minus 50, negative 25, okay, 12.5 minus 25, so negative 12.5, okay, so 6.25, subtract 12.5, negative 6.25. And at that point, I'm going to stop there because, yet again, we're starting to see those numbers all over again. You could try it one more time to see that, that this would be negative 3.125. Okay, so do we always get the exact same numbers? No, not necessarily, but you can still see an exponential pattern, something being multiplied or divided. So here with the next one, all right, so 10 minus 2, you should know that one, is 8. 50 minus 10, whoopsie, is 40. 250 minus 50 is 200, and 1250 minus 250 is 1,000. Okay, so those are the values that we need right there. Okay, so we had 8, 40, 200, and 1,000. What I'd like you to notice is here, 2 times 5 is 10. 10 times 5 is 50. What's 8 times 5? Should be 40. And 40 times 5 is 200. And 200 times 5 is 1,000. So we start to get a pattern that, okay, it's still showing the same pattern of multiplying here. So we talked about common ratios, and that's how we handle these here. So our first part is, on this one, so we want to take the value below it, so 25, and we want to divide it by 50. And we want to simplify. So, actually, this worked out really well like that. Kind of like that. Okay. Okay, so then 25 divided by 50 gave us 1/2. Over here, okay, so we're going to take 12.5 and divide it by 25. The calculator gives us 0.5, but remember that this is the same as 1/2. Can you use either number? Whichever one you prefer. Okay, between these two, and that's going to be over here, so that's 6.25 divided by 12.5. Alright, so 6.25 divided by 12.5 is 0.5 again. And so we can do this one more time. So we can take those two, and we'll do this one over here. So 3.125, divide that by 6.25, and we get 0.5 again. So what can we say about this guy? This guy has a common ratio, and it equals 1/2, or if you prefer the decimal, 0.5. Okay, so this is what we would call an exponential decay situation. Not growth, because the values are decreasing. So when the values increase, we call that exponential growth. And so the last part we'll see is to find this common ratio. So here, as we do these, so we have 10 divided by 2. Each one of these, so we have 50 divided by 10. Next one. So we have 250 divided by 50. And the last one, we have 1250 divided by 250. Okay, so let's go divide. What do we get each step of the way here? Okay, so 10 divided by 2, I think we know that one. 50 divided by 10, I know that we know that one. 250 divided by 50, oh, are we seeing a pattern? And 1250 divided by 250. So what we get each step of the way as we divided, we got 5, 5, 5, and 5. So this table has a common ratio equal to 5. And to finish this off, before we do example 3, to have an exponential relationship, the common ratio must be constant. Okay, so let's try one that doesn't look as nice. Okay, so from here to here, so we're taking 6, and we're dividing it by 4. Alright, so here to here, I'll leave us a little space, so we're taking 9 and dividing it by 6. Okay, over here, so now we're taking 13.5 and dividing it by 9. And then here, we're taking 20.25 divided by 13.5. Okay, so this may seem kind of odd that we have all these different fractions, and it doesn't look like they're going to give us the same values. But let's try it out. So what's 6 divided by 4? Okay, we get 3 halves. What's 9 divided by 6? Okay, we got 3 halves again. What's 13.5 divided by 9? And that's 1.5. Now what you can do is you can press menu, number, and approximate to fraction. And so by choosing this, I can take the 1.5, my previous answer, and turn it into, 3 halves. Okay, and the last one, so we have 20.25 divided by 13.5, and we get 1.5 again. So what we can say here is that this table has a common ratio equal to either 3 halves or 1.5. Alright, ladies and gentlemen, definitely show that work as you're completing your assignments. At the very minimum, I'd like to see the change amounts, but you may not want to show the division or the subtraction. Try to show me as much as you can so that I don't have to guess that you took it from elsewhere.